Okay, so this is how you fill the table. Two things I would like to quickly draw to your attention here. In this example, it so happens that most of the time the minimum value is obtained when you pick the newly introduced currency. But in this grid alone, it happens to be that not picking the new introduced currency is what leads you to the minimum value. So generally, if you see 3,6 na 3 is made by picking that coin, 6 is made by not picking. 2,3 na 2 is made by picking that new currency, 3 is made by not picking. And so in most cases, picking that new currency helps you land up with fewer coins. But here, 3 coins if you pick this new one, 2 coins if you don't pick. So it so happens that in this case, not picking can help you land up with fewer coins. So the point I need to drive home is that either of the two situations may be the case. If you pick it, you land up with fewer coins. If you don't pick it, you land up with fewer coins. Either of it can be. There is no such rule that it is always picking the coin which leads me to fewer number of coins required. It depends on the denominations, on your exchange value and so on. So that is one point. And like I said, your answer, finally what the question wanted you to find out is how to make 10 rupees using all these denominations in the minimum number of coins. So you go to your exchange value 10, you go to this final denomination which includes all of this, which is your bottom rightmost cell. That will be your final answer. So in this case, the final answer is you need only 2 coins to make 10 rupees if you have all of these denominations. That is what is written here. So now you know how to fill the DP table, hopefully. At least you have the optimal substructure. If you practice, I'm sure you'll get it. And you know how to find the final answer, which is just look at the bottom rightmost grid. And that will tell you what is the minimum number of coins, but it won't tell you what are those actual coins. And that is an important thing I'd like to draw to your attention here. A DP solution to an optimization problem is always a number, the maximum or minimum value that you are looking for. The actual configuration of parameters that led to this value is not directly given by the table. You have to do something called backtracking. So I'll explain what that is. So see, if I give you this coin change problem and I'm telling you minimum number of coins, obviously I want to know what are those coins also. Just telling me 2 coins is not sufficient. I'm obviously going to ask you what coins, what are those 2 coins, 5 rupees, 5 rupees or 6 rupees, 4 rupees, what are the denominations is obviously going to be my next question. But that is not directly an optimization question, right? When I ask you what are the coins, that's not an optimization question directly. Your DP is generally used only for optimization purposes. So your table will only give you the optimum value at any point. To find out what configuration of variables leads to that optimum value, you have to do something called backtracking. So what it does is it starts from the end, the solution you just derived, and you go backwards, and at each step you see what you included, what you did not include. So in this context, you'll start from 10 rupees, you'll go back to 0 rupees, and at each step you will see which coin I picked, which coin I did not pick. There is a specific technique to doing that, which is what we're going to look at in the next slide.